There is no physical connectivity between transmitter and receiver. Radio transmission provides a higher transmission rate. Narrowly focused in the sense what? Both the antennas must be aligned. What kind of data or what kind of signals we are going to transfer? That is electromagnetic signals. So, hello to all, a warm welcome to my new session on the physical layer. I am your Revati ma'am, faculty from the Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. So dear student, in my last class, I started with guided media. So what is guided media? That is nothing but the wired connection. So dear student, suppose if two nodes want to communicate each other, then they must require physical connection between two nodes. To establish physical connection, I required cable. All the cables comes under guided media. So it is also called bounded media. Why? Because it is capable to cover only shorter distance or shorter range. For that reason, it is called bounded media or wired media. And some of the examples for guided medias are twisted pair cable, coaxial cable and fiber optics. But in my today's session, I am going to deal with unguided media. So what is unguided media? It is nothing but the unbounded media or wireless. So if I want to transfer the data at the large distance or for the longer distance, I am going to use unguided media. And how I am going to send the data? Only through the air or through the free space. For that reason, it is called unguided or unbounded. So, I am not going to have any restriction. Example for unguided medias are radio wave, microwave and infrared. So, dear student, in this session, I am going to deal with unguided media along with its types. So, what is unguided media? It's also called by the name unbounded or wireless media. So, wireless in the sense what? Suppose sender and receiver want to communicate, then we does not require any physical connectivity. In the sense what? I does not require any wire. Then how these two parties are going to communicate? That is via the air or via the free space. So here unguided media is also called as unbounded or wireless media. And to transfer the data, we are going to use free space. And what kind of data or what kind of signals we are going to transfer? That is electromagnetic signals. So I am going to transfer electromagnetic signals. And how I am going to transfer electromagnetic signals? That is throughout the free space. That's nothing but the air. So here there is no physical connectivity. In the sense what? I am not going to have any wires. Suppose if I want to connect with sender to receiver or receiver to sender, I don't have any physical connectivity. And how I'm going to connect? Only through the air. So, there is no physical connectivity between transmitter and receiver. So, who is transmitter? That's nothing but the sender and receiver. And this type of transmission media is applicable for longer distance. If I want to send the data only for smaller distance, then I can able to use wired. And if I want to send the data across the globe or across the country, then I'm going to use unguided media. The best example for unguided media here is wide area network or mobile network. So dear student, if I consider wide area network, we are using wide area network to cover throughout the globe or across the country. So the best example for unguided transmission media is wide area network, that is WAN and mobile network. So dear student, let me to discuss the types of unguided media. There are three types of unguided media, that is microwave, radio wave and infrared. Anyway, we are going to study the type of unguided media one by one in detail. At the beginning, I am going to have radio wave. Now, think that we are familiar with the radio station and we are going to have only one radio station, but we are going to have n number of radio listeners. So how many stations? One. And how many radio listeners? We have n number of radio listeners. Now, whatever the signal I am going to get, that is going to cover all the direction. So, dear student, the best example for radio wave is radio station. So, radio waves are the electromagnetic waves or electromagnetic signals that is carried through the air. So, all the electromagnetic signals are carried through the air. So, electromagnetic waves that are transmitted all the direction of free space. So, free space is nothing but what? That's nothing but the air. So, I'm going to have the radio wave or electromagnetic wave or signal that is carried through all the direction using air. So, radio waves are omnidirectional. So, what is omnidirectional here? All the signals are carried through all the direction. So, the signals are propagated or carried in all the direction. So, here signals are carried in all the directions are known as omnidirectional. Think that I have one radio station. And I am going to have the n number of user. I am going to have the n number of user. And all the electromagnetic waves or signals are propagated in all the direction so that all the users are able to get radio station. The range in the frequency of radio waves is from 3 kilohertz to 1 kilohertz. And in the case of radio waves, sending and receiving antenna does not align. In the sense what? I don't want to align sender and receiver. Why? Because whatever the signals I have, that is propagated in all the directions. So, no need to align the antenna. So, the sending and receiving antennas are not aligned. In the sense, the wave sent by the sending antenna can be received by any receiving antenna, because microwaves are propagated in all the directions. So, sending and receiving antenna does not align. The best example here is FM radio. Now, let me to consider the applications of radio wave. In the sense what? Where I am going to use radio waves? When I want to broadcast multiple signals. So multicasting. Okay, when I want multicasting, then I'm going to use radio waves. So what is the meaning of multicasting? One sender and many receiver. Okay, so radio station and n number of viewers are the best example for radio waves. Along with that, television as well as cordless phones are the best example for radio waves. Now, dear student, I am going to have the advantage. What is the advantage? Radio wave transmission is mainly used for wide area network and mobile cellular network. So here radio transmission is mainly used in the fields like wide area network. It's mainly used to cover longer distance, and it's also used by the mobile cellular network. Radio waves are responsible for covering larger area or long distance, and it is also responsible for penetrate the walls. So penetrate the walls in the sense what? Cross the wall. Signals are capable to cross the wall. For example, if I take cell phone and I am in the room or I am inside the room, suppose if I want to make a call, I can able to make a call because radio waves are capable to penetrate the walls. In the sense what? Radio waves are capable to cross the walls. So that is the very important characteristics of radio wave. That is penetrate. Radio transmission provides a higher transmission rate. So it provides higher data transmission rate. Now I am going to have the microwaves. So here microwaves are nothing but the electromagnetic waves, and all the waves are transmitted in unidirectional. So unidirectional in the sense what? Only one direction. For that reason, sending antenna as well as receiving antenna must be aligned. For example, consider this is one antenna at the sender side and this is the another antenna at the receiver side, and both the antennas must be aligned because it is unidirectional and it is responsible for sending electromagnetic waves or electromagnetic signals. When an antenna transmits microwaves, they can be narrowly focused. Narrowly focused in the sense what? Both the antennas must be aligned. So the sending and receiving antenna need to be aligned. Now let me to consider the characteristics. What is the frequency range we can have here? That is 4 to 6 gigahertz to 21 to 23 gigahertz. And bandwidth capacity, it supports the bandwidth from 1 to 10 megabits per second. And if I use microwave for shorter distance, then it is inexpensive. In the sense what? I required minimum cost. Suppose if I use same microwave for the longer distance, then it is expensive. In the sense what? As the distance increases, I must have to increase the size of the antenna. So it is expensive as it requires a higher tower. Tower in the sense what? That's nothing but the antenna for a longer distance. The next characteristics here is attenuation. So due to environmental condition, microwaves are get affected. So environmental condition in the sense what? Due to air, rain, okay, the electromagnetic waves are get affected. So attenuation means loss of signals. So signals are going to vary due to environmental condition as well as noise. So these are the characteristics of microwave. Now let me to consider the advantages here. Microwave transmission is cheaper. If I consider microwave and I'm going to send the data using microwaves, then it is cheaper. Because if I consider guided media like twisted pair, coaxial or fiber optics, for the wires I have to pay the money. But here microwave transmission is cheaper than using cables. And it is free from land acquisition. To construct the antennas or tower, I required very small space. And by using single antenna, I can able to cover n number of clients or users. It is free from land acquisition as it does not require any land for the installation of cables. If I consider cable, I require land for the installation. But if I consider microwave, I does not require any land for cable installation. Microwave transmission provides as easy communication in territorians as their installation of cables in territorians is require a difficult task. So what is the meaning here? If I take hill areas to install cables, it is very difficult. Okay, by using microwaves, I can able to provide the services to hill area. Even I can able to cover the range throughout the world. Okay, so microwaves are responsible for covering longer distance. Communication over ocean can be achieved. See here, it does not require any physical cable installation here by using electromagnetic waves. How I am going to send the electromagnetic waves? Through the free space or through the air. So I can able to cover or communication over oceans can be achieved by using microwave transmission. Now dear student, I am going to have the disadvantage. What is the disadvantage? Out of phase signal. So dear student, if I consider any signal, that is sine wave, okay, this is my sine wave. And if I consider any wave, I must have the phase frequency as well as amplitude. And if I consider microwave, due to noise or environmental condition, the phase of the signal may vary. A signal can be moved out of phase by using microwave transmission. Another disadvantage here is it is susceptible to weather condition. Here microwaves transmission is susceptible to weather condition. This means that any environmental changes such as rain or wind that destroys the signal. So dear student, if I consider microwave, to transfer the microwave, I am going to use free space. If there is any environmental changes that directly affect the microwave transmission. The another disadvantage, bandwidth limited. allocation of bandwidth is limited in the case of microwave transmission. So dear student, by using microwave, I can able to cover only the shorter distance. Suppose if I want to cover more longer distance, then I'm going to use radio waves. So the most commonly and most frequently used unguided media is radio waves. Now, if I consider infrared, this is the third type of unguided media. And what is infrared waves? Infrared waves are used to cover very short distance, in the sense within the room. The best example here I can able to consider TV remote. They cannot penetrate through obstacles. In the sense what? If I take remote signal, okay, that is the infrared waves or infrared signal. Is it possible to cross the wall? For example, think that you are in your bedroom and you want to turn off the TV. Is it possible to turn off or switch off the TV? No, because infrared waves are not able to penetrate the walls or obstacles. In the sense what? It's not able to cross the wall or cross the building. What is the frequency range? It supports 300 gigahertz to 400 terahertz. So it is responsible for covering only shorter distance, and it is used in TV remotes. The best example, TV remotes, wireless mouse, keyboard, printer, Bluetooth data transfer, all those things are the example for infrared. So it is responsible for covering only shorter distance. And by using infrared waves, we are not able to penetrate the walls. Data transfer between two cell phone, TV remote operation, data transfer between a computer and cell phone resides in the same closed area. So within the room, I can able to transfer the data. Now, characteristics of infrared. It supports high bandwidth. The capacity of data rate is very high. So it provides high bandwidth and hence the data rate is very high. Infrared waves cannot penetrate the walls. In the sense what? Cannot cross the walls. Therefore, the infrared communication in one room cannot be interrupted by the nearby rooms. So dear student, by using infrared waves, I can able to cover only shorter distance. In the sense what? Only closed area. So an infrared communication provides better security with minimum interference. Suppose if two TVs are running and one person is going to turn off the TV in one room, that does not affect the TV which is running in another room. Even if I consider AC remote, that's also example for infrared. So infrared communication is unreliable outside the building. Think that I am standing outside the house and I am trying to turn off the TV or turn off AC. Is it possible? No, because sun ray will interfere with the infrared waves. So sun ray is going to interfere the infrared waves. For that reason, it's not possible to use the infrared waves outside the building. In the sense what? Standing outside of my house or home, I am not able to turn off the TV or AC. So these are the characteristics of infrared. So which are the example I can able to consider here? That is TV remote or AC remote, wireless mouse or keyboard. These are the example for infrared. Anyway, dear student, in my today's session, I started with what is unguided media. How to remember the topic? Unguided media in the sense what? There is no physical connection between two entity. Then how I'm going to communicate? Only through the air or through the free space. Example for unguided medias are radio wave, microwave and infrared. And dear student, in my next session, I'm going to deal with switching. So here I'm going to deal with what is switching, what are the different types of switching we have. Anyway, dear student, let's meet in the next session with the new topic, that is switching. Until that, keep watching and keep learning. Thank you.